In this lesson, we're going to run through limits. We'll start from the basics, what is a limit, and we'll evaluate limits, and then we'll run to limits at infinity, and then we'll do one-sided limits. Then we run to the special limits, and finally the asymptotes. So now to begin with, what is a limit? So a limit, we can first visualize it with this scenario. So imagine we have this guy here and we have this lady, and then now what happens when the guy approaches the lady like, hey, I'm asking for your line, but the lady will be like, no, you should know your limits. Yeah, so the guy should know his limits. So limits are simply boundaries. So now what does this mean in the aspect of mathematics? So a limit is just like we can put it something like a boundary. So a limit is a boundary. So in mathematics, the major boundary we have is an undefined function. Yeah, so we cannot have a function that is 1 over 0. If you punch this on the calculator, it will give you math error, syntax error. So this is the boundary, this is the limit. So we can never go to 0, whereby it's the denominator. Yeah, so this is the limit of a function. So now what do we have to understand about the limit? So I'll just quickly run you through, like let's say for example I have a function f of x is equal to 1 over x. So for this function, where there is x, if we put 0, then we're going to have 1 over 0, and 1 over 0 does not exist. This is the boundary. Yeah, so we can even imagine something like, let's put 2 over x. Yeah, so if we have 2 over 0, that's undefined. So now limits, it's whereby you try to become this guy. You try to see how far you will go, and you want to see what will happen when you just approach. You are just approaching the boundary. What will happen? So that is the idea about limits. We look at how far we can go approaching a certain number. So like in this case, we have said 0, we can never use 0. So but what happens if we now start approaching 0? Like let's pick numbers which are less than 0. So for example, if we pick a number which is very close to 0, like 0.9. So 0.9, we can have a function such as 2 over 0.9. Yeah, so this one it's not undefined because we can divide. So what do we get when you say 2 over 0.9? So if you do the math, you are going to get 2.2. Yeah, so now what if we increase this number, like we go a little bit closer? Let's say so here at first we've gotten 2.222, just 3 significant figures. Yeah, so now what if we increase this number? We say 0.99. What are we going to get? So if you increase, you are going to have 2.020. Yeah, so this number is smaller. This is 2.0, this is 2.2. So the number is decreasing. Yeah, so and then now what if we even get a smaller number, like we get 0.9, or a bigger number? If you get, so this 9 is close to 0, and then this one is closer. So now what if we get another number like 0.99? Yeah, like 4 9s there. Or you are going to have a number that will look like 2.000, and then there will be 2 somewhere here. Yeah, so here the relationship is that you can see that these values of x, when we're increasing the values of x, so these values are becoming greater and greater. Yeah, you can see the values are becoming great. 0.9, 0.99, 0.9999. So the more we increase these numbers, even this, the value of f of x, so this is the value of f of x, it also keep on increasing. It will be very close to 2. Like the other value will be 0.00002. If you add more 9s, again it will be 2.0000002. Yeah, it is very close to 2, but it is not 2, but it is very close. Yeah, so when we round off, it will just be 2. So, but here we cannot have it. Here we don't want to put 0. Yeah, we don't want to put 0, so we're putting 0 point something. So, the relationship which you can observe is that the more you approach 0, when x is approaching 0, then the limit is getting closer to 2. You're able to see, so these are the values of f of x. It is now getting very close to 2. So this means that the limit as x approaches 0, it is 2. Yeah, this is the idea behind limits. So you are really asked to show this. So this is just for understanding. Yeah, so we can do a lot more examples. Yeah, but I'm sure you've gotten it just from here. So now we have to now to evaluate limits. So when it comes to evaluating limits, if you are given evaluate the limit as x approaches 2 and you are given a function, it simply means this 2 you are going to substitute it where there is x. Yeah, so like for example, if we have the function is anything like 3x squared minus 4. So if we're to find the limit as x approaches 2, we're going to say this will be 3, while this x we put 2, yeah, minus 4. So this will be 12 minus 4, we get our 8. So this is the limit as x approaches 2. Yeah, so that's how you basically evaluate limits. So I'm sure there are no problems there. So we're done with evaluating limits. You see, very, very, very easy. But if you're going to study math without practicing, then you're not studying it. So these are sample tutorial sheet questions about evaluating limits. So we have all these. What can we try out? Yeah, so I'm just going to do one. So these you can do them very well on your own. So like for example, if I pick this one to evaluate the limit as x approaches negative 2, this will simply be, so we're going to say the limit as x approaches negative 2 in this function. So 2x squared plus 4 over 5 minus 3x. So we are going to substitute. So here you have to understand that when you substitute, so this limit, it should always be following down. Yeah, except when you substitute. So like at this point we're substituting, we're not going to write limit. We're just going to write negative 2 power 3 plus 2 negative 2 squared plus 4 over 5 minus 3 negative 2. Yeah, and then you finish it up from there. So this is negative 8 plus 4 times 2, it's 8 plus 4 over this is 6 plus 5, 11. Okay, well, I can just 6. Okay, yeah, so this is 5 plus 6. So from here you can finish it up. These will cancel. 8 minus 8 is 0. We're going to have 4 over 11. So this is basically what you do. So when you're told to evaluate a limit like this, you just have to substitute. You substitute and then you proceed. So but there are some times whereby you are going to find yourself that you are approaching a boundary. So this one you can find. I'm going to answer this one. Yeah, so these three you can evaluate them without difficulty. So the third one, this one, it looks a little bit different. So we just use the same principle. So we're going to substitute. So what is x? If we put 2 and then we have a square plus here we have a 2 minus 6 over x, we're saying what is x, we're putting 2. So you can see this is a problem because we're going to have a 0 and this is a boundary. So there's no way you are going to approach, you shouldn't approach a boundary. So this is a 0, 1 over 0. So this is a no-go area. Yeah. So when the function is giving you an undefined answer, you have to try and see what you can do about it. Yeah, so you have to change it, and then if it still gives you undefined, then it's just undefined like that. So like here we can factorize the numerator. We have x squared plus x minus 6 over x minus 2. Yeah, so what are the products, sum and factor of these terms? So the product is -6, and then the factors will be 2 plus, or 2 and 3. So the sum is 1. Yeah, so this is 1, and then the factors we can say 2 and 3. So 3 times 2 it is 6. So since it's a negative, one of these should be negative. So 3 times -2 is -6. And then when you add, you get a +1. Yeah, so from here you just quickly do the needful. X squared, so here we can write -2x plus, we can start with n. So like here I wrote 3 first, 3x minus 2x, and then at the far end we have 6. So this will be over x minus 2. So where will this lead us? So we'll just factorize. So here the common thing, it is x, and then we're going to remain with 1x, and then here the x has been factorized, will remain with a 3. Here when we factor out the -2, we're going to remain with x plus 3 over x minus 2. Yeah, and then from here first we should group the like terms. Yeah, so it is quite important to show all your working. So like this will be x minus 2 x plus 3 over x minus 2. So sometimes you can find that here is a plus, so you have to go, and if you find that here you're having a plus, so meaning this won't cancel, so you'd have to restart. You see why you're making a mistake. Yeah, and then if it's just correct the way you've solved, then well and good. So we cancel. And then here I forgot, so like there are some strict lecturers who expect you to always bring down this, especially when we go to differentiating using the first principle. There you can never forget this. You always bring down limit as x approaches 0. Yeah, so up to this point we say limit as x approaches, or not 0, it's 2. So I've remained with x plus 3. So what is x? When we substitute, that's when we stop bringing down this. So x is 2 and then 3. We're going to get a 5. So that's how you go about it. And then where's the other question? So we can now look at question 5. So question 5 also requires you to factorize x minus 5 over x squared minus 25. So here you can be able to see that the numerator can be simplified. This is the difference of two squares. We have a minus 25 can be written as 5 squared. Yeah, and then from here this will be x minus 5 over x plus 5 and x minus 5. So this is basically the difference of two squares, and then from there we cancel, meaning we're going to remain, so here on top we're going to remain with 1 over x plus 5. And then what was the limit? T was approaching 5, so meaning we're going to have 1 over 10. Yeah, so we've answered question 5, and then you should try question 8. So what are you going to get when you evaluate it? So you can show me your work you can send me your work on WhatsApp. So from here now we're going to deal with limits involving radicals. Yeah, so but here do you have problems? So you just have to factorize the numerator. Yeah, so when you factorize it, I think you can even see it is very similar to what we did there. So when you factorize, okay, let's even aside, we are going to have x minus 2 and x plus 3, and then this will be over x minus 2. So this will cancel, and then you are going to remain with like x plus 3. Yeah, and then there's a cube root. So you put 2 plus 3, 5. The cube root of 5, the answer should be around 125. Oh, not the cube root. The third power. Yeah, cubed. So you just factorize and you proceed. And then from there, let's quickly look at what else can we look at? So I want to ensure that you are able to solve majority of all these. Yeah, so before we go to these special ones, so these are the ones which you most frequently find in the exam, or one of these which look nice. Yeah, so your homework is question 7. So let's see what you're going to do here. So you have to factorize the numerator, also factorize the denominator, and then you see what will cancel, and then you proceed. Yeah, and then we have question 10. It is x power 4 minus 16 over x minus 2. So here this can be written as x power 4 minus, so 16 simply means 4 squared, so this is over x minus 2. So what will this mean? So this means that we have a difference. So what do we have? x power 4, okay, and then we have that. So here we're simply going to say, so we'll say this can be written as x. So power 4, we can write it as x squared, but it is having another square. So according to the rules of indices, a power of a power, you just multiply. So this can be written like that. And then we have 4 squared over x minus 2. And then what is the purpose of writing it as a power like that? So we have a difference of 2 squares. We have this square and this square. So meaning we can write, we have one thing here, it is x squared minus 4, and then we're going to write x squared plus 4. So the difference of 2 squares simply means one will be plus, the other one will be minus, the other one will be plus. Yeah. So the squares, this square and this square, they have been distributed. Yeah, so I hope you are not so confused. Yeah, but you can always let me know, like, okay, why is that? Yeah, so ensure you always practice. You always encounter such. You might think that it was very straightforward, but it will require you to do something. Yeah, so and then from here we can simplify further. We're going to say, so this is over x minus 2. So we can simplify one part. We can say that, so this is x squared, so this is x squared minus 4, so what is 4, we can put 2. Yeah, x squared minus 2 squared, and then this is x plus 4. We'll just leave it like that. So we just want to cancel the denominator, because the purpose of us doing all this is because the limit, which you are not supposed to forget, I'm just doing it for the sake of space and time. So the limit is approaching 2, so 2 is our boundary. We can't put 2 here because we're going to have a 0. So this will be the difference of 2 squares. We have a minus, one is having a square, the other one is having a square. So we're going to write x minus 2 and x plus 2. Yeah, then not forgetting we have this. And then we say over, everything is over x minus 2. Yeah, and then from here, when you just see the part where you're cancelling, then you divvy small and you're going to remain with x plus 2 and x squared plus 4. Yeah, so at this point you can quickly substitute and then you find the answer. So when you put a 2 here, this will be 2 plus 2, 4. And then when you put a 2 here, that is 2 squared 4, 8. So are we getting 32? Yeah, so I hope that's the correct answer. Yeah, so this is how you solve. And then let's do one more. Let's do one more. We're still evaluating the limits. What else can we do? Yeah, so we're just looking at rearranging. So like here on question 12, when you see this question, why there's t, when we put 0, then it's not going to make sense. 0, 0, 0, these are undefined. So then for this one, you have to make it as a single fraction, and then you try and see what you can cancel. So this will be 1 over t minus 1 over t squared plus t. And then we make as a single fraction. So I'm just doing this as a summary. I know that you understand. T is approaching 0. So when we express as a single fraction, this will be t times, okay, so we'll just write t, we'll just write t and then t squared plus t. So t squared plus t times 1, we're going to cross multiply, we're going to have t squared plus t. We have a is it plus or minus? Yeah, so t minus t, t. Yeah, so from here you can, we have a t minus a t. So at this point you can see we'll just remain with a t. Yeah, so t minus t is 0. It has cancelled. So we have a t squared over, so we can open the brackets. Let us say we're going to have t cubed plus t squared. T times t squared, t power 3. T times t, t power 2. Yeah, and then from here we will factorize now. So I have t squared over, we can factor out the t squared, meaning here will just remain with 1t, because 2 of them have gone outside, and then here we say plus 1. We factored it out. So cancel, cancel. So we couldn't replace here because this will be 0, 0. It won't make much sense. Yeah, so from there we're going to have 1 over t plus 1. At this point, at least now you can substitute. That's when you also stop dropping down limit as x approaches 0. Yeah, so I emphasized this on the lesson we had on WhatsApp. You should always bring it down. Yeah, so 1 over t plus 1. So where there's t, you can put a 0. It's going to be 0 plus 1, which will just be 1. So the answer is 1 over 1. Yeah, so which is just 1. So that's how you find that. What else can we do? So we've answered this, that. We've answered this. This is an homework, or this is a homework. Yeah, and then we've also answered this. So the only one remaining for simplifying the expression is that one. Yeah, so can I give you this as homework? You should. Okay, let's do it real quick, under 1 minute. 1 over 4 plus 1 over x. Everything is over 4 plus x. So you have to make the numerator as a single fraction. Yeah, so the numerator, we're going to have 4x, x plus 4. Yeah, over 4 plus x. So here we've just multiplied x times x, x. X times 1x, 4 times 1, 4. Yeah, so from there you just you just say I will have x plus 4 over 4x, and then this is divided by 4 plus x. So we're going to have x plus 4 over, so this is over 1 over 4x times 1 over 4 plus x. So this is just the same as writing x plus 4. They are both positives, so they can cancel. So meaning we're going to remain with 1 over 4x. And then what is the limit being approached? The limit is x is approaching negative 4. Yeah, so this is 1 over 4, negative 4. We are going to get 1 over negative 16. Yeah, so I think the work was just here to simplify. So at least I've given you a glimpse of what you have to do. So you should ensure to practice on more questions. Yeah, some will require you to to understand algebra very much. You should be able to simplify in all angles. Yeah, so now we're just going to do like one example from these. So we did this. Which example did we do in our lesson on WhatsApp? We did this. So we can try something new. I'm going to answer this one. Let's evaluate the limit as x approaches 0. So initially we can substitute. So what are we going to get when substitute? On top we're going to have a 0. Okay, so this will be 3 plus 0. So when you substitute with a 0, we're going to end up with 0, 0 over 0. When you simplify the numerator, it's going to remain a 0. So when you have a 0 over 0, it is called an intermediate. Intermediate, meaning it is not undefined, but it is just very near to being undefined. Yeah, like you are not close, you are not yet at the boundary, but you're almost there. Yeah, so this is an intermediate. So I'll have to simplify it, and then we try and see if we can work around it. So we have x over square root of 1 plus 3x minus 1. Okay, so what's required? X over 1 plus 3x minus 1. So here we have to multiply by the conjugate. So since the radical is on the denominator, then we're going to multiply by the conjugate of the denominator. Yeah, so what's the conjugate of the denominator? It is the same thing. So I have 1 plus 3x and then minus 1. Yeah, so I'm sure immediately I've written minus 1, you'll be like, hey, why do we have a minus? Yeah, so you know very well a conjugate, it's a plus. So since here we have a minus, then the conjugate is a plus. Yeah, just a quick recap: if the function is a plus b, then the conjugate is a minus b, and vice versa. So at this point we're going to multiply. What is x times all that? It's going to be x multiplying the whole lot of it, 1 plus 3x minus 1. So you have to be careful not to write it under the radical. Yeah, so over. So I've showed you repeatedly how to simplify this when you are multiplying a number by its conjugate. So let's just do a very quick one. So let's say you have something like a plus b, and then you are multiplying this by the conjugate a minus b. What you simply do is you get one thing, you put a square, and then minus the other thing, you put a square. Yeah, so this always works very well. You can try it, or you can always do the normal one: a times a times b, b times a, b times b. Yeah, so whichever method you choose, that's okay. So to quickly do this one, we're going to say we have so we're going to get one part, we square it. So we're going to have the square root of 1 plus 3x squared, and then always put a minus in between, and then the other thing, it's 1, and we also square it. Yeah, so from here we just go on. So the numerator initially didn't have a radical, so somewhere things will cancel. So you just hold on, you do not expand until you find it's necessary. So here we'll say the root will cancel with that. So we're going to remain with 1 plus 3x minus 1 times 1, 1. Yeah, so and then this 1 minus 1, it is 0. So it is more like the two are cancelling each other. And then from there we're going to remain with x square root of 1 plus 3x minus 1. It's equal to, oh, it's over 3x. Yeah, and then this x and this x can cancel, meaning we're going to remain with root 1 plus 3x. We have a minus 1. So remember, I was telling people not to put the negative inside there. Yeah, so it will be like that, over, we're remaining with a 3. So we can substitute what was x approaching in the question. X was approaching 0. So what is x? We can put 0. We're going to remain with, so here when you put a 0, you're going to have 3 times 0, 0. You're going to have a 1. You're going to have a 1. 1 minus 1 over 3. Okay, so this doesn't look nice. And then you're going to have 1 minus 1, 0 over 3. So like I'm getting a 0. Yeah, so you can solve through. Yeah, so sometimes the answers might not be convincing. So whenever you doubt your answer in a test or an exam, you can quickly run it through. Yeah, so I don't want to start over. You can go through, and then if there's a correction, you take note of it. Yeah, and you can also let me know, like, oh, there was a mistake somewhere there. But I hope you've understand the process. So let's do one more. Let's do one more example, and then I will go to the other things. We'll go to infinity and all the other crazy stuff. So what if we have this one? The limit as x approaches 0. So here you can see if we put a 0, this will be undefined. So what we do, we'll multiply by the conjugate. Where is the radical? The radical is on top. So I'm multiplying by the conjugate of this thing. So we'll say times x squared plus 100. While there is a minus, we put a plus, over x squared. So always remember, when we're multiplying a radical, when we're multiplying something by its conjugate, you just get one part, you square it, minus the other part, you square it. So this will be square root of x squared plus 100 squared minus 10 squared over x squared. So remember, I'm multiplying, so this isn't supposed to be x squared. It's supposed to be the same thing, x squared plus 100, and then outside we have a plus 10. So this is what we have. So we have x squared plus 100 minus 10. Yeah, and then from here we just simplify. We can see that this square and the 2, they will cancel. We're going to remain with x squared plus 100, and then we have a minus there. 10 squared, it's 100 over. So here we'll leave it first like that. We're going to see how things will cancel, if at all they'll be cancelling. So this is x squared minus x squared plus 100 minus 10. So 100 minus 100, we can see it will go away. And then we have x squared, it will cancel with this x squared. So everything that was on top has gone away, meaning we'll remain with a 1. Meaning we'll just remain with 1 over root. So even this has gone. So 1 over square root of x squared plus 100 minus 10. Yeah, and then what are we going to get? Oh, and is everything okay here? Okay, so here I started making a mistake. So we've multiplied by the conjugate. So this is plus plus. I started writing minus. So this is that times x squared. Yeah, so this is plus and going just like that. So plus. So this will be the limit as x approaches 0, 1 over. So since I now want to substitute, then I don't have to drop down limit. So this will be square root of what is 0 squared? 0 squared plus 100 plus 10. Yeah, so 1 over square root of 100 plus 10. And then from here, this will be 1 over 10. Square root of 100 is 10 plus 10. The final answer is 20. Yeah, so this is how you work it out. So such questions, you would expect them to come as multiple choice. Like you are told, when you evaluate the limit, what are you going to get? Is it 1 over 10, 1 over 20? They even put some negatives. Yeah. So now, at this point, we'll say, I will have evaluated the limits. Yeah, so and this is where the lesson, which started on Google Meet, ended. Yeah, so we're just quickly going through the evaluation of limits. So now let's go to the other components. Finite limits at infinity, one-sided limits, special limits, and asymptotes. Yeah, so all this will now be in the next recorded video lesson. Yeah, so let us take a break. We'll continue in the next lesson after this one. Yeah, so we're going to continue with evaluating limits, but it will be limits at infinite. Yeah, which is this one. Yeah, so we'll end here. See you in the next lesson.